Hey everyone, we're going to do one more very short topic here dealing with thermodynamics, or about the way an engine breathes, and talk about the way that high altitudes cause an engine to lose power. As you know, the amount of oxygen in air decreases as you go up in altitude. Uh, and in fact, there's a simple rule of thumb for reasonably low altitudes that says that in general, for every 1,000 feet of elevation you gain, you will lose about 3% of the oxygen available. Now, the oxygen is necessary for combustion, so if we lose 3% of our oxygen, then that means that the engine will also lose 3% of its ability to produce power for every 1,000 feet of elevation. So you can say that in general, an engine loses 3% of its power for every 1,000 feet. Now, as a point of reference, that's compared to the sea level engine output. Vehicles are always rated by what they produce at sea level. Anything above sea level, they produce a little bit less. Here in La Crosse, we're about a little over 1,000 feet of elevation. The Rocky Mountains out west are anywhere from 10 to 14,000 feet of elevation. And of course, the highest spot in the world, Mount Everest, is about 30,000 feet of elevation. But nobody's driving up there. So here's the formula you need. The amount of horsepower that you lose is found by taking the horsepower that the engine produces at sea level, which is where they're rated, times your elevation, and that's got to be in feet, divided by 1,000, times 0.03, that represents 3%. And if you crunch that, that gives you your horsepower loss. So a very easy formula to use. So that's a very easy formula to use. Let's look at a couple of examples. So our first one, how much power is lost when a 5.9 liter Cummins in Denver, Colorado? Now Denver is got an altitude of about 5,200 feet. That's about a mile. That's why Denver's called the Mile High City. That engine is normally rated at 160 brake horsepower. That's at sea level. So anybody who buys a truck in Denver knows that they are not going to get as much power out of it as the TV commercials say they are. So we can use our formula. The horsepower loss is found by taking our horsepower at sea level, which is 160, times our elevation divided by 1,000. So in our case, that's 5,200 feet, divided by 1,000, times 0.03. And pretty easy calculator problem. 160 times 5,200 divided by 1,000 times 0.03. And if you do that, you end up with about 24.96, or about 25 horsepower lost. Okay, let's take that one step further. Do a slightly different problem here. A 2011 Chevy Silverado with a 5.3 liter Vortec produces 315 brake horsepower at sea level. What's the power output? Now, this question isn't saying how much do we lose. The first question we asked was how much power is lost. This one is what is the power output on Grandad Bluff right here outside of La Crosse, which is about an elevation of 1,210 feet. ASL means above sea level. Well, first we figure out how much our loss was. So our horsepower loss is going to be our rated or brake horsepower at sea level, that's 315, times our elevation of 1,210. I didn't label it, but those are in feet, divided by 1,000, times 0.03. And if you take your calculator and multiply 315 times 1,210 divided by 1,000 times 0.03, you will end up with about 11 horsepower that we lose. So even here in La Crosse, our vehicles don't get as much power as they are rated for. So 11 horsepower lost. Then the question is, how much will it produce? What is the power output? Well, we started with 315 minus the 11 that we lost, and that leaves us with 304 horsepower. So I would like you to do this one for practice. Take a minute and tell me, how much power will a 52 horsepower motorcycle have at the top of Pikes Peak, which is about 14,115 feet above sea level. This problem is from personal experience. I'm a motorcyclist, and a few years ago I was in the Rocky Mountains, and I was at some pretty high elevation, and my motorcycle was noticeably lower on power because of that elevation. Go ahead and do this problem. Unpause when you're ready to see that solution. Okay, so pretty straightforward. The amount of horsepower we're going to lose is our rated brake horsepower times our elevation, 14,115 feet divided by 1,000 feet times 0.03. That means we're going to lose 22 horsepower. That's nearly half of the engine's output because this is a really, really high elevation. This is one of the highest peaks in the United States that you can access by vehicle. Okay, so our power output will be 52 horsepower minus the 22 that we lose, and that leaves us with 30 horsepower, and that answers the question. So we're down to about half. Okay, one more. What's the horsepower output of a Peterbilt in Nebraska, which is a little bit higher elevation than us, 1,300 meters. Now, we're at about 1,200 feet. Nebraska is about 1,300 meters. Nebraska is getting close to the Rocky Mountains. Nebraska is at a reasonably high elevation compared to where we're at. Now, this is just like the other problems we've done, except for our altitude is in meters. We need to convert meters into feet for this problem. So we're going to take 1,300 meters, and we need to convert that into feet. There's several ways to do this, but based on the conversions that we've used a lot, we know that 1 meter is 100 centimeters. We also know that 2.54 centimeters is 1 inch. And of course, we know that 12 inches is 1 foot. So we canceled off meters, we then canceled off centimeters and canceled off inches, and that leaves us with feet. So our altitude turns out to be 1,300 times 100 divided by 2.54 divided by 12, and that gives you 4,265 feet of elevation. And now we can answer the question. Our horsepower loss turns out to be about 92.7 or about 93 horsepower lost. That's substantial. So what is our output? Our output will be the original 725 minus the 93 that we lost, and that leaves us with 632 horsepower. And that answers the question. So the problems that you do will all be one of a few types. Be careful to read the problems carefully. Sometimes you will be asked how much power is lost, which is of course what our formula tells you directly. Some problems will ask you what is the power output, and of course then you would subtract what we lost from what we had, and that will be our power output. And just like this one, some of your elevations will be given in meters, so then you should convert those into feet before you go ahead and use the formula. But this is it. This is the one formula for today. Your horsepower loss due to high elevation is your horsepower at sea level times your elevation divided by 1,000 times 0.03 or 3%. All right, that wraps this short one up. Go ahead and do those problems and send those to me. Let me know if you get stuck.